Amabelle Santos from Pamantasan ng Lungsod ng Maynila, and today, we're gonna solve a problem from Hamilton's and Simpson's Quantitative Chemical Analysis from Chapter 9, Item 9.50. So, the problem goes like this. A sample is known to consist of sodium hydroxide or sodium bicarbonate or sodium carbonate or possible combinations of these together with inert matter. With methyl orange, a 1.10 gram sample requires 31.4 ml of HCl, of which 1 ml per 0.0140 grams of calcium oxide. With phenolphthalein, the same weight of sample requires 13.3 ml of the acid. Calculate the percentage of inert matter in the sample. So, based on the problem, we can deduce that the volume of the pH is equals to 13.3 ml and the volume of the methyl orange is equals to 4.8 ml. The 4.8 ml can be computed by subtracting the 31.4 ml to 13.3 ml. Then the answer to that will once again be subtracted to 13.3 ml in order to solve for the volume of the methyl orange. So, continuing, the methyl orange can be solved by multiplying 4.8 ml, the volume of the methyl orange, to the molarity of the HCl. The molarity of the HCl can be computed through stoichiometry of the calcium oxide. Let's first convert it to moles first. 1 mole. The answer will be 2.4964 times 10 raised to negative 4 mole divided by 1 times 10 raised to negative 3 liters. So the molarity of the HCl will be equals to 0.24964 m, and this molarity will be multiplied to this 0. Computing, we will be able to solve for the mmol of the sodium bicarbonate. So now that we have the moles of the sodium bicarbonate, we can compute now for its grams. So 1.1982 mmol multiplied to 1,000 milligrams. The answer will be 0.1006 grams of sodium bicarbonate. Now for the phenolphthalein, we can compute for the sodium carbonate of that. We first multiply 13.3 ml to the molarity of the HCl, which is 0.24964 m. And the answer will be 3.3202 mmol of sodium carbonate. Now that we have the moles of the sodium carbonate, let's solve for its grams. So 3.3202 mmol multiplied to 1 mmol, then the 9.95 milligrams, then 1,000 milligram, then 1 gram. The answer will be 0.3519 grams of sodium carbonate. Now, let's compute for its percentages in relation to the sample. Percent sodium carbonate can be computed by dividing its weight to the weight sample, which is 1.10 gram multiplied to 100. Its answer will be 9.14%. Then, the percentage of sodium carbonate is equals to 0.3519 grams So, divided by the weight sample, 1.10 grams times 100, the answer will be 31.94%. Now, to compute for the percent inert matter, we simply have to add these two, then multiply it to 2. So, percent inert matter is equals to 100% as a whole minus 2, the factor needed in order to solve for the problem, then the percentages of sodium carbonate and sodium bicarbonate, which are 9.14 and 31.94%. Solving this equation, we will get 17.74%. And that is the percent inert matter in our sample of 1.10 grams. That's all. Thank you.